Hi, my name is Scott D'Amico. I'm with Intel Corporation. I'm a technical marketing engineer focusing on the graphics capabilities that Intel has in their second generation processor here. I'm at CES 2012, so welcome. What I'm showing here is the 3D experience that you can actually get off of Intel's second generation processor, along with several different third-party applications that are taking capabilities of the second generation processor and using those to give you this 3D experience. So I'm going to start from basically the creation or the caption of the content all the way to the displaying of the content itself. So what we're doing to show this capabilities is, first of all, we're using a product from GoPro, which allows you to capture the content. It's a very popular camera out there that people use today for extreme sports. So if you've ever seen some of these videos out there where people jumping out of airplanes or surfing or snowboarding and having pictures of that, they're using most likely this camera. Recently, GoPro has come out with the capability of now capturing two-dimensional videos, so really a view from the left eye and right eye at the same time that are all time-stamped together. And what this allows you to do is it allows you not to just get a 2D image of what the extreme sports person is seeing, but now, because there are two-dimensional videos, through the use of their software and the power of the Intel platform, you can now create a 3D image of what you got to now give that user yet a different experience and get more in what the actual sports person is actually seeing when they're on the slope itself. So what we do to do that is you take both of the images, the left image and the right image, and now you have to create some depth perception of that actual image itself. So the software is doing that, and to do that, that is very intensive to actually make that happen, because you have to analyze each object and pixel in each of the frames and all the frames of that. So to do that, it's very CPU intensive to do that within the software. GoPro has really optimized their application and taken full advantage of the Intel processor to take advantage of all the cores that are built in the processor to do that. Once it actually does that depth perception of each of those frames, it then has to put it in a format that is viewable by the audience in some sort of player, whether it's a Blu-ray player or a soft player like we're showing up here. And that is also something that's very intensive to do that. What Intel has done with that is we've put dedicated hardware inside of our second generation processor that allows you to accelerate that conversion of that video into that 3D world itself. Okay, and what that does is it offloads the CPU from doing it, which gives them more headroom to do this 3D conversion process for depth perception. But more importantly, what it also does is it frees up the CPU from doing that, but it puts it in dedicated hardware, which costs less energy to actually run. What that comes back to the end user is it allows you to operate longer on the actual platform itself. So you get longer usage. So not just more headroom for the CPU, but longer battery life is what you'll get as well. So what we're doing here is I'm gonna launch the transcoding of that, and you'll see up here is that these cores will fill up all the way. So do that, and that's that 2D to 3D depth perception it's doing. What you also see is down here is I'm showing you basically what the CPU is doing from a graphic standpoint. So the media acceleration. Right now it's actually playing back a video, so it's using some of the graphics capability inside of here. So part of the built-in visuals of that. What we're gonna do when we start doing the conversion process is we'll use some of the more of the built-in visuals, which we call quick sync video technology, and it will actually show some of that type of capability in there as well. So you'll see not going from 40% here, but more like 80% that you'll start using that. So I'm gonna go ahead and click that really quick here and start a transcoding. And so what you're gonna see here is that the cores will go up there. We're not gonna compromise the video that's playing here. It's still playing at the same frame or anything, but now the cores are mapped, and now we're transcoding the video, okay, from these two-dimensional videos into a 3D video, and then we're saving it away so view later, in case like this on a third player and stuff. So you can see the cores are doing, the processor capabilities and the graphics capabilities is actually pegged up as well, taking full advantage of the platform, still not compromising the video and transcoding the video. By using the dedicated hardware and hardware acceleration in the platform, you're getting this happen faster and saving battery life by doing that as well. Once it's transcoded, then it's going to be pushed out to like a social network, put on a Blu-ray player, whatever you want, so you can actually play that back. What we're showing here is we're playing it back on a third-party package called ArcSoft Total Media Theater, which is basically a soft player playing the video back, again, using the capabilities of the platform, so using the built-in visuals of the processor for decode and also for what we call video pre-processing, so like the resizing, color conversion, things like that. And that's what's consuming the processor to actually do the playback. And then it's also using what we call in true 3D, which is giving you the 3D aspects to that. So taking the capabilities that we built into our processor and our driver and using that to actually display this on the technology. Again, giving you a full end-to-end experience from the actual capture of the content to the creation of the content, to uploading it or storing it on a CD itself, to the actual playback of the content, going from the slopes down to a typical user that I like to see with the professional sport scene.